Assalamu alaikum everyone. I am Ahesan Ullah from the Department of CSC at Kumil University. Today I am going to present a topic that is very important in digital electronic, the clocked RS and JK flip-flop. Firstly, you know what is flip-flop. A flip-flop is the most basic memory element in digital electronics. It stores one bit of binary data, either 0 or 1. Flip-flops are used in sequential circuit and are essential for data storage, timing and control in modern system. Types of flip-flops. There are various types of flip-flops such as SR flip-flop, clocked RS flip-flop, JK flip-flop, D flip-flop and T flip-flop. Each has unique characteristic and application. What is clocked RS flip-flop? The clocked RS flip-flop is a synchronous version of the basic SR flip-flop. It is controlled by a clock pulse, meaning its output change only during a clock edge. This helps avoid problems caused by level triggered design. This is the diagram of RS flip-flop. Truth table of clocked RS flip-flop. The truth table shows how input S and R behave with the clock. If clock equals 0, no change. If clock equals 1 and S equals 1 R equals 0, then output is set. If S equals 0 R equals 1, output it is reset. If both S and R equal 1, this is an invalid state, which is a limitation of this flip-flop. Characteristic equation of the clocked RS flip-flop. Q next equal S or Q and not R. This means if S equal 1, then output becomes 1, which is set. If R equal 1, output becomes 0, which is reset. If both are equal 1, output remains the same. Limitation of RS flip-flop. The major issue is the invalid condition when both S and R 1. This leads to unpredictable output and make it unsuitable for toggling or advanced sequential logic. Now we are introducing to JK flip-flop. To overcome this issue, we use the JK flip-flop. It's an improved version of the RS flip-flop. Instead of S and R, we have J and K inputs. It can toggle and has no invalid state. This is the diagram of JK flip-flop. Truth table of JK flip-flop. When clock equal 1, J equal 1, K equal 0, then set. When J equal 0, K equal 1, then reset. When J equal K equal 1, then toggle. When both J equal K equal 0, no change. This makes it very useful in counters and memory systems. The characteristic equation of JK flip-flop is Q next equal J and not Q or not K and Q. This expression shows how the JK flip-flop updates the output based on its input and the previous state. Advantage of JK flip-flop. No invalid state, can perform set, reset, toggle and no change. Useful in counters, frequency division and memory circuits. More reliable and versatile than RS flip-flop. Application of both clocked RS flip-flop and JK flip-flop. Both RS and JK flip-flops are used for basic data storage and simple state machine. ZK is preferred for more complex tasks like counters, shift register and frequency dividers. RS is still used in lattice and debouncing circuit. Comparison of clocked RS flip-flop and JK flip-flop. JK has an invalid state. On the other hand, JK does not. RS cannot toggle, JK can. JK is more versatile and frequency used in practical system. RS is simpler but limited in use. Conclusion. To sum up, flip-flops are building blocks of digital electronics. RS is simple but limited. JK flip-flop is more powerful and preferred for sequential circuit. Understanding this helps in designing memory, counters, and control units effectively. Thank you everyone for listening.